Hello, my name's Julian Edgar, and I'm the author of a bunch of books on cars and car modification, including aerodynamics, and as you can see here, also electronics. I've done 2 books on electronically modifying cars. One's called Car Electrical and Electronic Systems, and the other one's called Modifying the Electronics of Modern Classic Cars, cars of the 1990s and the 2000s. What I want to do in today's video is I want to talk about programming Arduinos. Now, this is a subject which I've had nothing to do with for years and years and years. Why? Well, to be quite honest, I was pretty concerned about having to learn how to use a programming language. All those arcane symbols, get a full stop or a semicolon in the wrong place and it doesn't work. And the other reason was I had a tame company that would pretty well do that for me on my request. They'd develop the hardware, they'd program it, and basically they'd just send me the product and I could have a play. But that all changed when I discovered XOD, XOD, XOD. It's a programming language that suits Arduino Unos like this, also Arduino Megas, the whole lot. Now, if you're not familiar with what these boards are, they're basically a full control board available for almost no money these days, maybe $5 US. So it doesn't even matter if you blow it up, you just go and buy another one. And they have the ability to take a whole lot of inputs and put out a whole lot of outputs, and you can control the logic. You can control the logic by writing the software, the sketch as it's called, in XOD. So, what's XOD? Well, before we get to XOD, here's how I actually use the hardware that I'm about to describe. So on the bottom left, down here, there's the Uno, in this case. Up here, there's what's called a screw shield, which plugs straight into the Uno, and these screw shield connectors means you can easily just connect any wires without having to use funny little pins. And here, obviously an LCD that then plugs in on top. So this forms a triple layer sandwich: the control board, the connecting board, and then the LCD if in fact you choose to use it. They're all as cheap as dirt. Unbelievable change over the last 10, 15 years. But what actually is XOD? Well, I've been using XOD because I write for an English electronics magazine called Practical Electronics. I've been using XOD over the last few months to develop a whole bunch of projects. None of them are car projects as it happens. Up here, we have a push button timer. The timer goes for however long you press the button. So if you can have it in 5-minute increments, 2 button presses, 10 minutes, 3 button presses, 15 minutes, and so on. Down here, we've got a thermometer that actually shows the temperature, a room thermometer, shows the temperature in flashes of light. And up over here, we've got a DC ammeter. It measures current draw, including instantaneous current draw, the sort that you get when you connect an electric motor or something like that, an inductive load. So I've been using XOD for a whole bunch of projects, and it is just so easy. It is unbelievably easy. So you're all breathless. You're all wanting to know, what is XOD? How do I use it? Okay, well, to get hold of XOD, you go to the XOD website. It's a free download, the complete operating system, the IDE, the complete system for the Arduino, free download. They've got some excellent tutorials, not just a whole bunch of silly YouTube videos like this one. They've actually got step-by-step tutorials to take you through the programming. I think there's about 20 steps, and after the first 10, if you haven't got how to do it, then you're probably never going to, but it really is straightforward. So that's the first step. But I want to show you in this video some of what it can achieve and how it achieves it. Now, what XOD comprises is a bunch of boxes that they call nodes, but I just think of them as boxes that you click and drag into place on a screen. You then do connecting lines between those boxes to show how the program should work, and then you upload it to the Arduino and away you go. So here we've got a 2-box program, 2-box sketch. We've got an analog sensor input, which is working on port AO. That's the pin you connect to on the Arduino. Simple as that. We've got it feeding a signal to what's called a PWM load, pulse width modulation load. That's the output. And all we do, we write down what port we're using for that. All we do is draw the connecting thing. Now, what could this do? Well, this is a motor speed controller. All you have to do is to use a pot on the input, use a MOSFET module on the output, in other words, to be able to handle the higher current. You turn the knob and the average voltage on the output will change. You can drive a motor speed over different speeds with just a 2-box XOD program. It really is that simple. And incidentally, if you're thinking PWM, MOSFETs, what's he talking about? That's where those books that I was talking about earlier, my books come in. It gives you all that background where you'll be able to then pick that up and apply it. So here we have a 2-node sketch, and yet it's a fully fledged motor speed controller with a pot input, a knob. Turn the knob, the motor speed will change. Let's have a look at another one. What we can do next is we can add another box in between those two. We still have the same input, the analog sensor input, which could be a pot or it could even be a temperature sensor. Now start thinking how you can control motor speed with temperature, say a pump on an intercooler. Anyway, I'm getting away from it. We've got an analog sensor input, but now we do what's called a map clip. These boxes are all pre-made. You just click on them, drag them in, and you know they're all there for you. No programming, writing, and code required at all. Now, what this does is it says, all right, I've got an input. In this case, that input goes between 0 and 1, and we can change those numbers. What do I want the output to go between? So when the input is 0, what do I want the output to be? And you can see here, I've said it should be 0.3. Now, in XOD language, 0.3 means a 30% duty cycle. Going up to, that should have been a 1, not a 0. I've made a mistake. So from 0.3 to 1, corresponding to an input of 0 to 1. Now, what does all that mean? It means if you're driving a motor, it'll never go slower than 30%. You've set the parameters, you've set the boundaries by using this map clip box. So here, you've basically got a motor speed controller. It's got a minimum speed of 30% and a maximum speed of 100%, and it's just 3 boxes. Now, if you're thinking, oh, that all sounds a bit complicated, you can actually add what are called watch boxes to the program, so you can watch what it's doing, and then you run it in what's called a debug mode, and you can actually see the program operating. It's actually getting feedback from the Arduino. You can actually see it working in real life, and you can see if it's working in the way that you want it to work. So here we have just 3 nodes, and yet we have now a reasonably sophisticated motor speed controller. How long does it take to do that programming? Oh, about 30 seconds. How long does it take it to upload it to the Arduino? Oh, about 10 seconds. It's just extraordinary. Let's have a look at another one. Now, I don't want you to panic because this is obviously a lot more complex. But what we've got here is we've got a program, a sketch, that detects rate of change. Rate of change. Now, if you imagine feeding this from the throttle position sensor, it will be able to detect when you put your foot down fast, or if you set it up differently, when you lift your foot fast. Now, I've used these rate of change detectors in the past to trick auto transmissions into going to a sportier mode. I've used these rate of change indicators to turn on intercooler water pumps. When you start driving hard, the pump turns on automatically, and it's just watching how fast you're moving your foot, because obviously the harder you're driving, the faster you tend to push down on the throttle. But the other thing that you can see in this particular sketch is you can change the variables. So we've got the analog input, we multiply it by 500, which is, I won't go into reasons why for this particular video. We then have a delta, a rate of change box. That box is pre-made. You just grab it and put it in. You don't have to do any of the software within it. We've got a clock. Every half a second, it looks at the sample and sees whether it's changed. We then feed that to a greater than box, and if it's greater in this case than 10, we turn on an output relay for a period of time. So for example, you can use it to put an older fashioned auto trans into power mode for 10 or 15 seconds, whatever you want, every time you move your foot fast. So the things that you can easily change that we've built into it, you can change the time for the sample, you can change the sensitivity, how quickly you have to move your foot before it will actually activate the output, and we can change how long the output stays activated for. Now, if you look at that and you think, oh, there's lots of boxes there, but if you break it down, it's actually really, really easy to understand and really easy to modify. So you've basically got a software programmable rate of change switch, which has got so many uses in a car and made basically from scratch. Let's have a look at one more. Now, it's getting complicated and it's probably now too small for you to see on your screen, but this is a fan speed controller. This is one of the projects I've done for that English electronics magazine. And I'm not going to go through each of the nodes, each of the boxes, but down the side, we've got an averaging period. This is a temperature input. So we're turning on a fan and changing the speed of that fan based on temperature. We've got the period over which we're averaging the temperature. We've got the temperature at which the fan will start. We've got the hysteresis, the difference between when the fan starts and when the fan stops in terms of temperature. We've got the temperature for the fan to be running at maximum speed, and we've got the minimum duty cycle, which we'll run the fan for. Now, that program, exactly as it is, could run a intercooler water pump on a water-air intercooler system. With a big enough output MOSFET, it could run a car radiator fan, steplessly controlling the speed. I'm actually using it here on my workbench to control the speed of a fan in a power supply. Now, again, I made it from scratch. It's a XOD program. It's not very hard to do. It's very easy to modify, and it's free. And as I said earlier, with the cost of Arduinos, with the cost of MOSFET modules, a MOSFET module that could run a reasonably powerful fan costs $5 US, even less sometimes. It's just absolutely extraordinary what can be achieved with this software, just with a bit of logic, because of course the program is quite logical in its layout, and a little bit of familiarity, couldn't get it out, familiarity with what those XOD boxes can actually do, what those nodes can actually do. And just before I leave you, here's a project I've just finished doing, again for Practical Electronics magazine in the UK. It's an automatic plant watering system, and it's not just as simple as it looks. It actually measures the moisture of the soil. It adds some water via a pump, just a simple windscreen washer pump and reservoir, and then it waits for an hour for that water to percolate through the soil, and then it does another assessment. And the further it is from the set point, if you want 75% moisture and it's only on, say, 40%, so there's a big difference between those two values, the further it is from the set point, the bigger the addition of water. It's a proportional controller, and it actually uses a PID node from XOD. Yes, XOD has even got PID functions built in, the sort of thing you use with boost control systems, the sort of thing you use with idle speed control systems in cars. Can I really recommend it? I think it's a fantastic software. It's free. I'm not getting paid anything to say this, but it's just absolutely revolutionary in what you can achieve so fast and so simply without doing a single line of code. If you want to read more about the background of the electronics, not XOD in particular, I do recommend either this book or the previous one I showed you. This one's Modifying the Electronics of Modern Classic Cars, Complete Guide to Your 1990s and 2000s Cars. And that and the previous book would give you easily sufficient background for the electronics that you need if you're going to employ Arduinos and XOD. Thank you.